Hey everyone, welcome to my channel. In this video, we are going to learn how to run object detection on a drone. We will first look at object detection and then embed it to the drone. And no, we are not going to install 100 packages with 50 different configurations. You will have your model running in 10 to 15 minutes. Speaking of drones, we are currently hosting a contest with the theme drone surveillance. Here, the participants are supposed to count the numbers of cars in a drone footage. That means you can participate even if you don't own a drone. And the 5 winners will get the latest robotics kit provided by MakeBlock, who have sponsored this event. And the winners will also receive a certificate from CVZone. So hurry up and participate. And if you would like to level up your drone programming skills, we have the Advanced Drone Programming course on sale for the next 2 days, where we will learn how to do face tracking, body following, gesture control, and a lot more. The link will be in the description. So without further ado, let's get started. So here we are in our PyCharm, and what I've done is I've created a drone object detection project, and this is the main file that is generated automatically. So we can use that. We will delete everything here, and then first of all we will go to the settings, and in the settings we are going to add our packages. So here the first one we will do is CVZone. We will install that, and this will install the OpenCV for us. Then we are going to install DJI TelePy, and we will install the version number 2. So let's hit that. And what else do we need? So that is pretty much what we require so far. And one more thing that we have to make sure, so Python OpenCV is not the correct version that we need. So what we have to do is we have to go back to OpenCV Python. We will specify the version, and we will use 4.4.040. So this is the one that works really well with the TeleDrone. So it doesn't give any errors. So most of the errors that I have seen previously are due to versions, and this version is quite stable for the TeleDrone. So we are going to install this instead. Okay, so now that this is done, we can go back and we can start with our coding. So first of all, we will import CV2. Then we will import Telo from DJI TelePy. DJI TelePy imports Telo, and then we will import CVZone. So these are the 3 packages that we will need. And then what we will do is we can try with a webcam, but yeah, let's do it with a webcam first. And once it is working fine, then we will add on the Telo part so that everything works fine. So we will write here cap is equals to cv2.video capture, and we are going to write in here 0, and then we will define the size. So we will write here cap.set. We will put 3 as the width. 3 is the prop ID number for the width, and the value is 640. So this is the width of our image. And then we will write cap.set and number 4, which is the height. So we can align it properly, and there you go. And now what we will do is we will write here while true. We are going to get the image from our webcam. So we can simply write here success, and image is equals to cap.read, and that is pretty much it. And then we will write cv2.imshow, and we will show the image. Image is img, and then we will write cv2.waitKey, and we will add a delay of 1 millisecond. So this is pretty much the standard of what we require to run. So what I will do is I will run this now, and you will see my webcam. I'm not sure if my webcam is number 0, or because I have a few of them. Maybe it is 0. Okay, so now it has opened up. There you go. So you can see my hand, and this is the TeleDrone we are going to test it on. And I have my phone here. We are going to test if it detects the phone. And we also have a book. We will test it with a book. And what else? Maybe this plant. and we also have a cup. So we are going to test all of these things one by one and see if it works, and then we will move on to the Telodrone. So that is pretty good. Now the next thing what we need is the files for our object detector. So we are basically using the MobileNet SSD. So what we will do is we will copy the files for it. So these files, you can find it on our website, Computer Vision Zone, and you can download it from there. You only have to sign in to get access to the code. So we will go in our Explorer, and here we are going to paste our files. So you can put it in a folder as well, which probably will be a little bit better. But here we are just doing that, and then I forgot one file. And there you go. So we have 3 files here. The first one is the names, and then we have the weights, and then we have the configuration. So we need these 3 files to run it. So we can close this now, and you will see all these 3 files are now here. And what we can do is we can import them. So first of all, we need to import all the classes. So we are going to write class names is equals to empty. So this will be a list in which we will add all the files, add all the class names, and then we will write here class file is equals to Coco names, coco.names. So this is the file. If we open it up, you will see it's just a text file that has all these different names, a total of 91 names. So we are going to use those. And what we will do is we have to import that in this list. We want it here. So how can we do that? We will write here with open, and then we will write class, extra bracket, we need to remove that, then class file, and then we will write RT. So we will open it up as F, and then we are going to write class names. Class names is equals to f.read, and then we are going to write dot splits, and then what are we splitting it based on? We are splitting it based on a new line. So we will write it in the quotations that we are going to have a new line. What did I do here? Okay, so this is basically the idea, and then you can write here prints class names, and that will give you the names of all the classes that we have done. Okay, so I actually bought a new keyboard and I'm getting used to it. So I'm making these weird mistakes. Anyways, so let's try that out and see if we get the names. Okay, there you go. So now all of these names are in a list. So you can see here, all till hairbrush. These are the names, and then we need to get our configuration file and the weight file. So we are going to write here config path, and then we will write here the name. Now it is quite a long name. I will double click it, and then I will click here and right click, and there's a rename option here, and we can simply copy all of this instead of writing it down because we are lazy, right? So that is the configuration, and then we have the weights. So weights path is equals to, again, we will do the same thing. We will open it up, right click, rename, copy, and don't make any changes here. If you make any changes, it will not work properly. So be mindful of that. Okay, we will put it in quotations. Okay, so that is basically the idea. And now that we have added these, we have the path for them, we can simply load it in a network. So we will write here net is equals to cv2.dnn underscore detection model, and then the detection model has the weights. This is the weights, and then it has the configurations of this. So these are the files that we will link to. And once we have linked them, then we are going to set the parameters. Now, these parameters you don't need to worry about. These are standard. I'm not changing these. This is as per the documentation. So I'm writing here net.set input size. So this will be 320 by 320. Then it will be net dot set input scale, and we will set it at 1.0 divided by 127.5. So this is half of 8 bits. And then we will write here net dot set input mean, and we are going to write here 127.5 and 127.5, and then again 127.5. So these are the mean values. And then we are going to set net dot set input swap RB. This is basically for you know that there is the actual values are RGB, and then OpenCV uses BGR, so you want to flip them, and they are saying yes, you want to flip them. Okay, so that is pretty much it. So these are the configuration parameters and everything we need to set before we can run it. And then we simply can go into our while loop, and we can call this function, we can call this method to give us all the bounding boxes, all the objects that it has found. So to run it, we are going to say net.detects. So, and then we are going to write here, we want to detect it from this image. And then we have the confidence threshold. So the confidence threshold, is basically the threshold that at which it will detect it as an object. So at what percentage do you count it as an actual object? So what we will do is we will declare it up here. So thresh is equals to 0.6. So if it is 60% or more than 60% sure that it is an object and this is the right object, then it will classify it as that. Otherwise, it will ignore it. And then we have the NMS. So this basically allows you to remove the duplicates within a bounding box. So maybe the object is detected more than once. So you want to remove that if you are using it in a counting project, or either way, you don't want to see duplicates. So here you can again put an NMS threshold, and we can copy that and we can paste it here, and here we are going to put it 0.2. So again, you can play with these values as you like, and you can see how well it performs for you. So next, what we will do is we are going to run our model. So actually the model is already running. We need to get their values. So we will write here class IDs. So these are the IDs that it will return. Then the confidence values and the bounding boxes of each of these that it has found. So these are the three things that we will be needing. And once we have these three things, we are going to use them to draw. So we can basically write here for class IDs. So this is IDs. So we will get one ID from it. So we will write it as class ID. And then we have the confidence values. So we will write here confidence, let's say. And then we have the bounding boxes. So we will write bounding box. So we are going to unpack all of this, but these are in different lists. So how can we do that? We can do that by using the zip method. So here we can write that we are talking about class IDs, but we will flatten it first. Flatten. Did I write the spelling correct? Hopefully. And then we are going to write here confidence values, and we are going to flatten it as well. Flatten. And then we are going to write the bounding box information. So we are going to write here bounding box. So now to test if everything is working, what we can do is we can print the class ID, and then we can print the bounding box. And what was in between? Confidence. Yes, we can print the confidence as well. So these are the three things we can print out and see if it works. So let's run that. I believe it will detect a mouse as well. So we have a mouse right up front. So there you go. So this is our mouse, and we are getting a warning. Tuple object has no attribute flatten. Interesting. Okay, but anyways, you can see here we are getting some values. So this is basically the class ID. It is 74. Then we are getting confidence level, and then we are getting the bounding box information. So this is basically the idea. Okay, so first of all, the error. We need to fix the error. For class ID, blah, 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 has no attribute flatten. Okay, I think when it doesn't detect anything, it might give this error. Let me try that again. So let's say it's detecting the mouse and the book. Let's put the book in as well. And what we will do is we will put a finger in front, and there you go. Yep, so that is the issue. So when it doesn't detect anything, it's giving an error. So we can simply write here, we can pick any of these, and we can write here that if there is something in the class IDs, then we will do all of this. So let's try it to see if it fixed that problem. No. Okay, so that is not good enough. We cannot use this. Okay, so that didn't work. So let's just put try. We are going to do the lazy way, and we will do accept, and we will pass. So hopefully that will work. Let's try that. So later on we can fix these issues. These are small things. It's not a big deal. Okay, so it's running, and if I put my finger, yep, it's not giving an error anymore, and yeah, it's working. It's not focusing. Focus. Okay, now it's focusing. It's not focusing here. Okay, it did. That's good. So now that we have this running, what we can do is we can use this information to actually print out the boxes. So you can use a normal rectangle, but the reason we imported CV Zone is to use the fancy rectangle. So what we will do is we will write here CV Zone dot corner rectangle, and then we will put in our image, bounding box, and that is pretty much it. So if you don't want to do anything else, you can simply run it, and that should print the bounding box on the image. So let's see how that goes. So it doesn't seem to work at all. Oh, I made a mistake here. It should be box, not bounding box. And this also should not be bounding box. It should be box. My bad. That's why it's giving more than what is required. Okay, let's try that again and see if it works. And yep, it does. Excellent. So there you go. So we are detecting a mouse, we're detecting a book, and let's see if we detect the cup. Yep, we're detecting the cup as well. Maybe my hand. Yeah, it's detecting probably a person. So that's pretty good. Maybe it will detect the drone as well. Let's see if it detects the drone. No, I don't think there is any class for that. But yeah, that seems good to me. Like, it's very stable. So if you want to remove the purple rectangle and just use the edges, then you can write here RT, which is the rectangle thickness, is equals to 0. So if you put that, it will not draw the rectangle, it will just draw the edges of the rectangle, which, you know, it is a little bit fancier than a normal rectangle. So let's try that. There you go. So it looks like that. So it looks like a target. So we can bring in our book. There you go. But it is a little bit confusing. Yeah, that's true. It's a little bit confusing, you know, when you're trying to find the right edges. But again, you can open that up. You can increase the thickness if you put 1 or 2 or whatever. I'm not sure what the default value is. It is RT is 1. Yeah, so the default value is 1. So you can change it to anything that you want. Okay, So this is all good. Now it is working. The next thing will be to put the text. So what we want to do is we want to add some text to actually show what class has it detected. So this is very important. So we are going to write, actually let's remove this. We don't need that anymore. And we are going to write here cv2.putText, and we are going to write in our image, and then we are going to write an f string, and in that f string we are first of all going to write the class names at what ID. So at what index number we are going to take the class ID -1, because if you remember it starts from 1. It doesn't start from 0, but in Python we are starting from 0. So I'm talking about the Cocoa names. It starts from 1. So we have to remove that by saying -1, and then we can write .upper to capitalize all of the names. So to me it sounds more, it sounds better to me if it is more capitalized. It looks better. So then we are going to also put the confidence value. So we can round it out, and we can write here the confidence value multiplied by 100, because it is in decimal places. We can multiply it by 100, and then we can say that the rounding off value is 2. So we don't want more than 2 decimal places. So this is basically our string, and then we can write the center point. So the center point will be the box, and what we will do is we will shift it a little bit towards the side. So we will say that the box at 0, so this is the x value plus 10. And then we will do the same thing that the box at 1, and we are going to shift it a little bit down. So to shift it a little bit down, we will add, let's say, plus 30. So it will shift that down, and we need to put those in brackets. Then we are going to write the cv2.font. Let's pick any font that comes up, and then we will write 1, and then we will write 02550, and then we are going to write the thickness as 2. So this is basically the idea, and it is going out of the image, out of the frame. So I'll push it down. And what else? So I think that should be good. Let's run that again. There you go. So now we are getting a mouse. It is 62% sure that it is a mouse. Then we are getting a person. It is 70% sure it's a person. Let's bring in a mobile phone. Maybe like this. I detect it as a remote. Cell phone, yeah. There you go, cell phone. And then a cup. Let's try a cup. There you go. Detects it as a cup. Maybe if we slide the mouse on the side. Yeah, that's good. So this is basically the idea how you can use object detection, how you can run object detection. Now, the next thing we will do is we will add our drone programming to it. So what we will do is we will use DJI TelePy, and what we are going to do, we are going to go down, and here we are going to write me is equals to telo.telo, and then we are going to write me.connect, connect, and then we are going to write print me.get battery. This is just to let us know what is the battery value, me.stream off, and then me.stream on. So this will start our webcam, and then what we can do is we can take off. We can write here me.take off, and we can push it further because normally it's at a very low height. So we can push it up. We can say me.move up, and we can give it like 80 centimeters. But this I'm not going to do now because we are going to test it on the table first. So once we are done, we can open it up. And then in the while true, when everything is running, After running all of that, we are going to send the values to our drone. But before we do that, we have to change this. So this is where we are getting the image from the webcam. I will not delete it, I will comment it. So if you want to use it with your webcam, you can use it too. We will write here image is equals to me dot get frame, get underscore frame read, and then we are going to write dot frame. So this will give us the image, and we will also remove this part because this is for the webcam. We will remove that. So we will go down here, and then we are going to write me dot send underscore RC control, and then we are going to send in these values, because if you don't send any values, it will turn off automatically. So it has that functionality. You need to send it some values. So we are sending zeros for now. So what you can do is you can use this methodology to actually follow the object as well. So let's just test this first, and then we'll discuss it later. So first we have to connect our Wi-Fi. So let me open the Tello drone, and I'm using the EDU version, but you can use the normal version as well. It will have zero effect on this. So this code will work for both Tello EDU and Tello normal. So I think it is open now. So we can click on Tello and we can connect. And I'll just make sure that it doesn't take off, because that will be bad. And we can run it now, and hopefully it will work. So the battery is 74%, and the stream off is okay, stream on is okay, and I think it is running. Yes, there you go. And there you go. So it is detecting, there you go. And if I bring it down, you can see it is detecting the mouse. This is the new keyboard I bought, so I'm getting used to it, at least at this point. Then, we have a potted plant. That's amazing. A vase and a potted plant. And then you have the cup. Let's try the phone. No, maybe I need to turn on the screen. So yeah, now it is detecting. So that is pretty nice what we are getting here. Now the next step would be to actually take off and try it out whether it is flying and detecting the objects or not. So this is basically the basics of how you can do object detection using the Tello drone. Now, if you want to take it a step further, what you can do is you can use this information of the bounding box, and you can lock it to one of the objects, and you can say to follow this object. And this type of methodology we used in our advanced drone programming course, where we logged in the body or the face, and we tracked it using PID controllers, and we also learned how to do PID tuning as well. And all of this was done within OpenCV and using the CV Zone package. So it is very easy to do, and you can use any of these objects and lock it to the drone, and it will follow that as well. So all of this information, how to do face following, how to do body following, or how to add more objects, a bounding box, and follow them, all of this is covered in our drone programming course. So if you are interested to level up your computer vision skills when it comes to drones, then do check out our advanced drone programming course. It is a fantastic course that is available at not a very premium price, but with premium content. So do check it out. And I hope you have learned something new in this project. And if you do have learned something, then do share it with your friends. And if you haven't subscribed or liked the video yet, go ahead and do that. And I will see you in the next one.